In this video, I would like to show you how to use Venn diagrams to show a relationship between sets and set operations. Well, a Venn diagram is a visual diagram that shows the relationship of sets with one another. And if you don't know what a set is, I'll explain it shortly. So firstly, I want to show you how we go about drawing a Venn diagram. We start by drawing a large rectangle. This rectangle represents all the set elements being considered and is called the universal set, which is represented by the letter U. Now, a set may be thought of as a mathematical way to represent collections or groups of objects. And these groups and collections of objects in real life could be such as a set of books, a group of students, a team of basketball players, a collection of baseball cards, collection or a grouping of numbers. And these sets are represented by a circle in the universal set. So this may be called our set A. And we may have another set of objects which we will call set B, which is also represented by a circle. Since circle A and circle B are not joined together, they are called independent sets. Often we call them mutually exclusive. In this video, I'm specifically looking at two set operations where the two sets are not independent. That means that they share certain elements together. And therefore, they are likely to look like this universal set. There are a number of set operations that you must understand, and they involve the union of the sets and the intersection of the sets and complements of the sets. And I want to show you how to represent these sets by shading them using the various set operations. So first of all, I'm going to show you how to shade set A. I have just shaded set A. If I wanted to shade A with a dash, which means complement of A, that will be everything except A. It virtually means the opposite of A. We can shade similarly set B and the complement of set B. Now I want to introduce you to an operation called A union B. The way I see A union B is I look at the letter in here and I see this as a V for everything. So I will say E, V, everything. So the U becomes like a V for me and I see A, everything with B. So you're looking at everything that's in A and everything that's in B. And now we've got another operation here which we call A intersection B. So how can I distinguish that one from the one above? I see it as A, and then I think of the N here as N above, and the rest of it is just intersection. So I use the letter N to help me identify this one. And what does intersection virtually mean? It means that you are only using what A has together with the B, not on its own. They have to both have these elements. In other words, A and B must have these elements. Now, how would we shape B intersection complement A? To do this, I'm going to draw lines through B, not shading it, but just drawing the lines through B. And now I'm going to crisscross again through the complement of A, and the complement of A was everything except the circle A. But you notice that my crisscrosses now I go in the opposite direction at right angles to the B, but I must not draw inside the circle A. So I'm very carefully going through this. And the reason I drew these lines at right angles is so that you could see where the intersection is. Now clearly you are able to see that the intersection here, exactly where they crisscross each other, which means we're looking in this area over here where I'm just going to highlight this in yellow, and that would be my intersection. So now how would a B union complement A look like? Once again, let's draw lines through B. And now let's draw lines through everything that is not A. But this time we're going to draw the lines parallel to this, to the ones that we've drawn beforehand. And so you can see that in this case, the B union A complement will mean everything that is drawn or shaded, which means that if I wanted to do this, it will mean these parts over here, and I'm trying to shade along here, and the blue parts here, and this part as well, because it is everything. It's like in a marriage, everything is shared between the two people, okay? It's not an intersection, it's everything. So everything in here now is a shaded part, then this is the union. So this should be enough for you to understand how to draw any sets together and find out what their intersections, what their complements, and what the union is. This is just an introduction to Venn diagrams. I want to, in the next video, give you an examples with real numbers and sets with real elements. I hope that you subscribe to this because you'll get notified straight away. I'll be making more of these videos with real problems soon and putting them on. So I would love it if you would actually also put a thumbs up or like this video. It'll help me tremendously. Thank you.